Hi, Steve here at the SJCOE Fab Lab, and kind of expecting a text. But that's kind of the topic that we're dealing with. We're talking about the Grade 8 TUSD STEM unit, and this is computer science support. Now, where the text comes in is that texts are sent through a network, and we're really going to be focusing on network communication. Specifically with these microbits. Now, before we get started talking about, oh, there's one. Before we get started talking about all the network transmission stuff, let's talk about, well, the computer science standards. Computer science has 5 categories in the California Computer Science Standards. There is computer systems, because all computation occurs on a physical system, even if it's your brain. Data and analysis, because computers are great at processing large amounts of data. Algorithms and programming, the coding that you think of for computer science, and impacts of computing, because we want these students, as we're giving them these engineering skills and all these computer science skills, to come up with solutions to problems that serve everyone. So, well, that was 4. Number 5 is networks and the internet. So, of course, the internet is this huge network of networks, and the way that all of these different computers are able to talk to each other, regardless of where they are, is that they kind of expect a message to be in a certain format, a protocol. You've kind of used protocols in a way. You know when you write HTTP before a web URL? Well, the P in HTTP stands for protocol. Anyway, let's talk about our 3 standards that we're dealing with in this lesson. The first is 6-8 NI4. Model the role of protocols in transmitting data across networks and the internet. Well, the code we write to send a message between these two is going to be a great model of the actual protocols being used on the internet. Explain potential security threats and security measures to mitigate threats. So students might consider something like encryption in order to make it so that the information sent isn't exactly the information you're looking for. Maybe a number is added to it, or maybe it's multiplied by something in order that the number sent is in a way, or can be in some way hidden as it's transmitted and then unlocked by the person who receives it. I.e., if I gave you a number, like I need you to know how many cookies we're going to have at lunch, but I don't want everyone to know how many cookies. We could agree in advance that whatever number I send is going to be 5 times the real number. So I'd send the number 25, and then you would just divide by 5 and go, oh, well, there's 5 cookies. Okay. And then 6-8 NI6, apply multiple methods of information protection to model the secure transmission of information. Well, one way that we could go about modeling or use multiple methods of information protection would be like we talked about. Students could actually show this in the code that they write. Let's get started. So, I'm going to go to make code. Now, there's so many different types of make code. Some of our other videos have dealt with make code for Minecraft and make code arcade. We're dealing with make code for microbit today. So I'm going to go ahead and click on that, and up comes, oh, all this. Okay, so I already wrote a couple of network transmission programs. Let's start a brand new program just to introduce you. Another text. Just to introduce you to coding on Minecraft. sorry, coding with MakeCode. So I'm just going to call this Hello World to get started. Okay, and all we're going to do is say, show a smiley face on the LED matrix, and we're going to show the string, Hello World. Okay, by the way, Hello World is the classic first program for programmers, so that's why we chose that. You'll notice one of the things I love about MakeCode is that there is a model of what's going to happen on our microbit down here in the corner. So I could even make it full screen, and then we could see what happens when I hit restart. Oh, that's the whole thing. Okay. Well, I'm going to go ahead and download the file. I can say show in Finder. A great thing about MakeCode is that it works on most devices. I can just copy and paste into, well, you might have just heard it download onto this device, which behaves like a flash drive. So I'm going to plug this into the battery, and now, oh, there's what we wrote. That is great. Okay, so now that we know that we can copy and paste a file that we code to program our device, let's look at how we can write code for networking. Now, the way to do that is to go to the radio category. And really, all I'm going to do to get started, get rid of that, and I want to deal with some input, namely when I press a button. I'm going to say when I press the A button, send a 0, and when I press the B button, send a 1. Okay, so now these devices are going to send a radio signal between the two. Well, how will I know that the signal is sent? Because I can't see radio. Well, I'm going to tell it, you know what, when you receive a number, how about you just show that number? All right, that's a pretty simple program. Well, I could copy it, but I'm going to save a little bit of time by just looking at the model. So I'm going to say A. Oh, hey, there we got 2 of them. Oh, sent to 0, it's sent to 1. Let's try the other way. 0, 1. It's great that we can test this out on our model. Models are a great tool for engineering. Let's make another program. This time, I'm thinking I want to send or create a texting program. I figure my protocol, what my program is always expecting, will be 3 values. Number 1, or 0, we tend to count from 0 in programming. 0 will be what I want to say. 1 will be who I want to say it to. And 3 will tell me what image I want to show. So kind of like sending a text. Let's try it out. Okay, so if I send, let's get started. I can send something like this. So 0 we said would who I want to send it to. Let's say I wanted to send it to my friend Randy. And what message do I want to say? 1. Hi. And then what image do I want to send? Well, let's go with smile. Okay, so we're expecting 3 things in any message. So let's duplicate this. Duplicate. I'm going to send one to my friend Dean. Hello. So I've got smile. I'm just going to send another smile. We'll call that one smile too. All right. So I'm going to send 2 different messages, but of course we need a program that's going to be able to interpret what these messages mean. Okay. So let's say when I receive a name and a value, well, what do I do with that? Well, I'm going to have it to store those. Let's see. Say who, what, and image. All right, so I've got 3 variables that I can set. All right, perfect. And what it'll do is we'll have some logic, an if case. Should be something like if the value is 0, then I'll set who to the name. I can duplicate that. If the value is 1, then I'll set the message, or what, to that name. And if the value is 2, then I'll set the image to that name. Okay. So now, anytime a message is sent, we store what information I received. What's our next move? Well, I kind of need to be able to show my message. So, let's say I always want to show a message. Given, let's just start out with all of my values being 0. So image is 0, the what, the who. Okay. So then I can check to see if they're still 0. If I've overwritten all of those values, then I know I've got a full message. So I could say something like, logic, if image equals 0, Okay, so that's a bug. Let me tell you about that. What's going on is they want my variable to be either text or a number. And for a second, I made something into a number and then set it to text. Those little symbols that we saw a second ago, like that, we're saying, hey, you did something wrong. Now they've gone away. Once I fix that. So I can say, as long as image does not equal that, in other words, nothing, and I also want to make sure, duplicate, that who doesn't equal that, the what, duplicate, the who, this is all going in. Oh, man. So as long as they are all not something, then I can print out a message. So I could say something like, say, show string. I could put together my statements. Should go something like, hey, variable who, duplicate, duplicate, hey who, just wanted to say, and I could put in what, and then I could have a condition, a rule that says if variable image equals, so if image equals, and our text would be smile, then what do? Well, I'm going to show a smile. This is smile 1, our first smile. I can duplicate that, because remember we had 2 different types of smiles. The text is smile 2. I guess a slightly different smile. That looks fun. Okay, I think we've dealt with everything. I can send a message back and forth. We have our protocol. We're expecting 3 different numbers. I'm also going to reset. Now I want to point out, this was a little bit complicated. You might want to start off with your students just being able to show an image on a microbit, or trying to have it show a message across the room before they send a message. And probably not start out with like 3 different parts to the message so that you need to put together text. We can make this much simpler. All right. So it'll now reset. Okay, let's check it out. So let's say I send A. Press. Okay, that's great. I'm sending a message to my friend Randy. Let's try this out. Cool. We just sent a text. This is awesome. Okay. I hope that you get a chance to try out just coding on the microbit. Have it show a smile, have it show a frown. Have an event where you press a button and it shows a different image. try it out a little bit before you move on to a network protocol. But networks aren't that hard. Just go ahead, start sending little messages. This was a larger one. You can send simple starter messages, parts of stuff, and consider how safe they are and how they can be made safer. And there you go. The kids are on their way to making great network solution tools that I guess we'll all be sending texts on in a few years. I hope you have a great time with this project. Bye.